So hello everyone, welcome back to my channel, Power Tech Academy. My name is Babak Nia, and this video is the second part of backup relay coordination video. And definitely you remember the first video, I started to talk about electromechanical relay backup calculation. So I started with load flow analysis and short circuit analysis. So, and this one definitely you remember was the single line diagram of the circuit I wanted to simulate and solve. My main relay is relay B and circuit breaker B. Tap is equal to 5 and time dial is equal to 1 is a standard inverse electromechanical relay. And I'm going to calculate tap and time dial for the second relay is a standard inverse curve. So next figure you can see a report I prepared from ETAP software is short circuit summary report, and definitely you know I need to use line to line fault the minimum value and three phase fault the maximum value. So I try to put the fault current I need, the maximum and minimum fault current between bus B and bus C in yellow and red boxes. So I need to use the minimum fault current to calculate tap setting for the backup relay. And I need to use the maximum current to calculate time dial multiplier. So minimum fault current is equal to 1179. Turn ratio for backup relay current transformer is 10,000 to 5. So current for backup relay, relay A is equal to 5.895. So to find the tap, I prefer to keep my Morse value something between 1.5 and 2. So I would like to divide this value by 2 and by 1.5. So I have 2.94 and 3.93. So this one is the best tap setting for this example. So if you try to back to your example, is electromechanical relay and available tap is 3 and 4. So I prefer to find a number between these two values. So time or tap setting for this relay is equal to 3. So let's keep our concentration on calculating time dial multiplier. Just to give you some idea, to calculate time dial multiplier, I need to start to find how much is trip time for the main relay. And definitely, you know, if I try to take a look to the curve, so at the beginning of the curve, when current is a small, difference between two curve, difference between time of two curve is more. And at the end of the curve, when current is very high, difference is smaller. And the reason is this logarithmic axis, logarithmic diagram. So to find time dial, the best idea is to use the maximum fault current. So between bus B and C, the maximum fault current is equal to 2434. For the main relay current transformer, turn ratio is 500 to 5 is 100. So main relay current is equal to 28.34. Tap for the main relay is equal to 5. So Morse for main relay is equal to 5.668. And definitely you remember tap time dial setting for the first relay is equal to 1. So intersection between 1 and time dial setting equal to between Morse 5.668 and time dial setting equal to 1 is my time. So trip time for the main relay is equal to 0.371. So to be sure, backup relay is waiting enough for the main relay, and if the main relay and is not working, backup protection will be activated. I need to add coordination time interval. So coordination time interval is due to error for CT, is due to a stopping gap for electromechanical relay, and recommended value for electromechanical relay is 0.3 second. And if you try take a look to the circuit, definitely, or single line diagram, you can see circuit breaker B needs 5 cycle as an operation time. So I need to add this operation time to my calculation too. So 0.371 is the trip time for the main relay, 0.3 is coordination time interval, and 5/60 is operation time for breaker. So trip time for backup relay should be equal to 0.754 seconds. So I have the trip time. My goal, my objective is to find time dial. So to find time dial, I need to calculate Morse. So Morse should be calculated based on maximum current 2834, and I am calculating the trip time for the second relay, backup relay. Current transformer ratio is 1000 to 5. So second relay, backup relay current is equal to 14.17 amp. Based on my calculation, tap for this relay is equal to 3. So Morse for backup relay is equal to 4.72. So I know how much is the trip time. I know how much is the mort. So I try to draw two orthogonal line. Intersection of these two lines is Lidl on their time dial equal to 2 is 1.97. So I prefer to choose time dial equal to 2. So I finished my circuit calculation. Definitely I can use my ETAP software for um, verification. So let's start with relay B. So you can pick relay B. You can go to your star protection and coordination, and you need to click on create a star view. So for sake of clarity, I try to modify the font size for current and um, for time. And definitely, if I explained about this one in first or second video about overcurrent protection or circuit breaker sizing. So what else I did? To be sure my calculation is correct, I try to grab this um, crosshair, and I try to put this crosshair somewhere very close to maximum current is 2841, and I can see the delay for this value is equal to 0.371. So I can show you part of my calculation related to this one. Take a look, 0.371 when current or maximum current was 2834 amp. So you can pick both relay, and we can see, and you can pick the both relay, and you can activate your star protection and coordination, and take a look what we will have in this condition. So if you would like, you can pick both relay. Again, same condition, press star protection and press create a star view. So I have my relay A and relay B. If you would like, I can right click on relay A, go to plot option, and I can increase the font size. So I prefer to use font size 16. So this one is my relay A, and I can do same things for relay B. Right click and go to plot option and try to change the ID size to 18. So I have my relay A, relay B. Relay A is my backup relay. Relay B is my main relay. So if you would like, you can click on this icon, and you can make a connection between these two curves. And definitely you can see I have some sort of time difference between these two curves. And if you would like, you can move this time difference to different location and see how much is the time difference in different location, how much is the time difference with respect to the current. So current is very small. As you can see, time difference is equal to 0.642 seconds. If I go current very close to 1000, time difference is approximately 0.965 seconds. And if I go somewhere close to 3000, time difference is 0.377 seconds. So definitely you can see everything is based on my design, and definitely you remember I started with the maximum current because I said so. For the maximum current, distance between these two curves, time difference between these two curves is minimum. And if I try to move to less current, as you can see, time difference is greater, time difference is higher. So if you did this one, I have another choice, and to show you my circuit is working properly. So click on the main Windows, and after that click on this icon, fault insertion. Grab this icon and try to put or connect this icon to bus C. So I put this one to bus C, and some sort of short circuit analysis will run, and based on this short circuit analysis, as you can see, my circuit breaker B is working first one, and after that circuit breaker A is working. So definitely this one is based on backup relay coordination concept. So as you can see here, my current is 1361 K 61 amp. So it's not minimum current, it's not maximum current. If you would like to have some number related to this condition, you can move your mouse cursor to this icon. It's called sequence viewer. Press this one and you can read the information. So current is 1000 or 1.361 k amp. Trip time for the first relay is 570, and trip time for the second relay is equal to 1286. So this current is not my maximum current, as it's not my minimum current, and unfortunately when I'm using ETAP software, I can't apply my fault somewhere between my transmission line. So definitely for this overcurrent protection, I need to apply or my fault in any point of the line. So to have some simulation and to have some understanding, my idea is to play with length of transmission line between bus B and bus C. So right now, this transmission line has 100 kilometer length. If I try to increase the length, transmission line has greater impedance. Fault current will be smaller. And if I try to reduce the length, transmission line has a smaller impedance, so fault current should be greater. So let's move or review 120 kilometer, or consider the length of transmission line 120 kilometers. So I set the length to 120 kilometers. I am going to grab this icon and consider or put the icon in the same location. My short circuit analysis is running, and as you can see here, my current right now is 1233 amp. So tripping time for the main relay is 616 millisecond, and for the backup relay is 1435 millisecond. So I can do this simulation a few times. I can set my length to 130 kilometers, same condition, grab the fault icon and try to apply the fault. So and see what's going on. Current is 1178, is very close to the minimum current for this circuit based on my design. And as you can see, trip time for the main relay is equal to 642 milliseconds, and the trip time for backup relay is 1510 milliseconds. So I can reduce my transmission line length and I can increase my fault current. I'm going to set this value to 1. So if I try to set this value to 1, fault is happen occurs somewhere very close to bus B. So current should be maximum current. So press OK, grab your fault icon and put it exactly in the same location. So take a look. Even for this high fault current, circuit breaker B is acting first, and after that circuit breaker A. And take a look. The trip time for circuit breaker B is very close based on my calculation, 373. And trip time for circuit breaker A is very close to my calculation, 762. So thank you so much. This one was coordination and verification of my coordination calculation for electromechanical relay. For the next video, I prefer to use 501 as a smart relay, and I am going to coordinate two 501 relay. Definitely for 501, we have more flexibility to set different type of curve, C1, C2, C3, C4, U1, U2, U3, and U4. So thank you so much. Don't forget to subscribe. And if you would like, you can press the like button. And if you have any question, you can write in comment section. So thank you.